This is example 2 for the Materials, Colors, and Mass Properties lesson. The first step to example 2 is again to open the starting point file. To do so, I'll select my design library, again my lesson 2 folder. I'll simply scroll over to select my lesson 2 example 2 starting point file. I'll double click it to open it and select OK when I'm prompted with the warning that this is an instructional file. By selecting somewhere in my graphics area, I'll collapse my design library, and then I can proceed to saving a copy of this file in my own working directory. To do so, I'll simply select Save As, navigate to the location where I've been saving my files for lesson 2, and then to minimize keyboard strokes, I'll select, not double click, just select my example 1 file. I can then rename it from example 1 to example 2, so now I have a lesson 2 example 2 followed by my name, and I'll select Save. With this file saved, we can begin applying our materials. You see, in this example, we're going to apply a material that will then force the color and the appearance to change. To do so, we'll select the materials area on the feature tree and right-click. We can see that we have a list of favorite materials as well as the option to edit the material. Since the material we want isn't on our list of favorites, we're going to select Edit Material. By selecting Edit Material, we're given a materials window. Let's go ahead and collapse Plastics so that we can see the full list of SOLIDWORKS materials. You can also note that at the bottom of the list, there's the option for us to create our own custom materials library. However, in our case, we're going to be using a standard SOLIDWORKS material. We'd like steel, so I'll select steel. And we're looking for stainless steel, so I'll select stainless steel and select Apply. So now we've applied stainless steel to our part. However, before we close out of this window, I'd like to take a quick look at the Appearance tab to see this is where SOLIDWORKS defines what appearance and color is applied for that particular material. Let's also take a look at the Favorites tab. This is where SOLIDWORKS remembers that list of favorites that we had. Let's go ahead and add stainless steel to our list of favorites. So I'll select Add, and we can see stainless steel was added to the bottom. Should I want stainless steel higher up on the list, I could select the stainless steel on our list of favorites and use the Up button to move it up throughout the list. I'm going to move it to the top so we can remember where it was and select Close. Now, we've made a few changes to our part, and the first thing I'd like to look at is the last thing that we did by adding the stainless steel to our part, as well as if I right-click, we'll see that we added stainless steel to our list of favorite materials. So in the future, we wouldn't have to go into Edit Material, we could just select stainless steel from the list of favorites. Now, the other thing is we've added this nice shiny stainless steel surface finish, as well as the dull gray color. On your computer, you might not see this nice shiny surface. And the reason is the nice shiny surface is generated by a SOLIDWORKS feature called Real View. Real View is a feature that can be turned on and off from the View Settings dropdown. If I select the View Settings dropdown, we can see that I have the Real View graphics option. Now, unfortunately, SOLIDWORKS doesn't support all video cards for the Real View graphics option. So it may be that this option is grayed out or not even visible. If that's the case, that means you have a video card that does not support Real View. For a complete list of SOLIDWORKS graphics cards that support Real View, you're going to need to go to the SOLIDWORKS website. Now, I'm going to turn Real View off so we can see what things would look like had you not had Real View. Let's go ahead and select Real View, and that'll toggle it off, and we can see now we just have a dull gray color. That was the color that was defined in that Appearance tab we were previously looking at in the Materials window. Let's go ahead and turn Real View Graphics back on. Now the next thing I'd like to do is apply a knurled texture to my handle. To do so, I'm going to select my handle, select the Appearances drop-down, and we're going to just apply the appearance to this face. So I'll select the face, and this time I don't want to collapse my task plane. Instead, I'm going to go to the Appearance Scenes tab on my task plane. Within the Appearance Scene tab, I'm going to collapse all my appearances so I can see the complete list, and then I'll select Metal, and then I'll select Steel. We can now see a list of appearances we can use to apply to that face. I'll scroll down and select my knurled finish. By doing so, we can see that we've applied a knurled finish to that face. I'm going to click in the graphics area to collapse my task plane. And now let's take a look at how we can scale this knurled finish. What we need to do to scale the knurled finish is go to the mapping portion of the Appearance Properties area. Within mapping, we can see the face that we've selected, as well as the mapping control, and this controls the axis, as well as gives SOLIDWORKS the ability to define how it needs to wrap the texture. So we can define what type of shape we've got the texture on. In our case, it is a cylinder. And if we wanted to, we could change the rotation of the mapping. However, 0 degrees was what we wanted. And the last thing we can change is the mapping size. So this does some rough adjustment for the mapping size. Now, if you notice, there's that blue and purple box that's changing as we change the mapping size. And if we wanted to create a custom mapping size, we'd simply come over to that box. And when we get the resize icon in one of the corners, we can resize the mapping size to a custom size. That's what we're going to do in our case. Let's just resize it to a nice custom size that has the knurl finished at each end of that handle. Once we're happy with the settings, we can select OK. And now we have a nice looking handle with a knurled finish. Again, I'm going to toggle Real View off so that you can see if you're using a computer that doesn't support Real View, you're not going to see that surface finish. Let's toggle Real View back on for those users that have Real View. Now, before we exit this example, I'd like to take a quick look at the mask properties. Because when we defined a material, not only did we define the appearance of this part, we also defined the physical properties of the part. So SOLIDWORKS now knows the exact weight of this part. To see that, we're going to select our Evaluate tab, and then we can select Mask Properties. You can see that Mask Properties also has the shortcut Control-M. Well, let's just go ahead and select our Mask Properties icon, and now we have a Mask Properties window open. I'm going to move it off to the side so we can see our entire model. Now let's take a look at the information that shows up on our Mask Properties window. We can see the density that's set for the material. So SOLIDWORKS knows that stainless steel is 2.89 pounds per cubic inch. We can see the volume of 2.4 cubic inches. So from that, SOLIDWORKS has calculated the entire mass of our part. We have a complete surface area of the part. Next on our list, we can see that SOLIDWORKS is showing us where the center of mass is in X, Y, and Z coordinates, as well as displaying it with a purple set of axes. If we continue down the list, we can see SOLIDWORKS has also given us the moments of inertia. When you get to the point of completing the SOLIDWORKS Certified Associate exam, you're going to need to know how to use this mass properties window, because the exam is going to ask you to draw a part, and then to verify that you've drawn the part correctly, it's going to ask you for the center of mass as well as the total mass of your part. Of course, if you've drawn your part wrong, then the mass is going to be wrong and the center of mass is going to be wrong. So again, you're going to need to know where this location is so that you can complete your SOLIDWORKS Certified Associate exam. Well, with that complete, let's close out of this window. And that concludes example 2. I hope it was a help.